But one thing I want to quickly go a bit deeper on is this idea of neurogenesis, right? So you mentioned that when you engage in physical activity, you tend to stimulate neurogenesis, right? Which allows you to really like increase your capacity for learning. So can you go a bit deeper on that? Because I think that's extremely important.
Yeah, absolutely. We used to think that neurons in the central nervous system didn't regenerate. And once you lost them, you lost them. And then
Yeah.
I think probably about 20 years ago, we realized that some regions of the brain in some animals, and that's actually quite important, in some animals, in rodents, they started to realize that you get new neurons. So if you have mice and rats running, exercising, you can actually see the markers for new cells in certain areas in the brain, in the hippocampus in particular, and the olfactory cortex. And there's a huge amount of controversy as to whether this happens in adult humans or not. Some researchers are absolutely sure we get neurogenesis, the new cells. Some are less sure. So I think what we can definitely say is exercise increases neuroplasticity, but I think we probably need to be a little bit careful saying definitely adult neurogenesis in humans, although a lot of people do think the evidence points in that direction. So neuroplasticity in general is really about neurons' capacity for, I guess, for change, for new connections. So they're like they're little cell bodies with lots of axons and dendrites which connect to other cells into a network. So we definitely know we can grow new branches, which means new possible connections to other cells. And information, memories, any thinking, if you like, is represented in a sort of flow of information and activity in these networks. So we can definitely say neuroplasticity is increased very significantly by exercise. Possibly slightly wary about saying we do get new neurons in adult humans because we're not so sure.
Okay, so what makes them not so sure? Because I've heard of this, right? So like what exactly makes people a bit, I guess, like to doubt, I guess, this idea of being able to increase your neurons through physical activity and so on and so forth? Like what's the main problem there?
I would have to wade through the research papers to find out, but it's very subtle and it's very hard. Typically, it's frowned upon to cut into the brains of live adult humans, so it's quite hard to do the research.
Interesting. Yeah, yeah.
Obviously, some people would argue whether that's okay for rodents or not, but certainly it's harder to do. It's harder to do the research in humans. It's done with sort of staining cells, and then with a kind of dye or radioactive dye that will show up. So then you're trying to scan an adult brain, and it's just very hard to get the resolution. It's very hard to be sure. My understanding, I'd have to read the literature a bit more to be sure, but I think it's some of it is it's a very technical discussion as to what the data actually means. So there's different research groups are interpreting some of the data that they see in a different way and saying, well, yes, maybe, but it could be this. And obviously with a good scientific approach is to say, until we have a better theory, this is what we believe. And some groups are saying we think it means this, and some groups are saying we think it means this. It's really interesting work, I think, and I think the idea was kind of revolutionary when scientists realised that definitely in rodents and some other animals, we get new cells. But one of the reasons why it's theoretically possible that it's not the case in humans is because our brain is so much more complicated. Adding new cells might actually, so the theory goes, adding new cells might actually be something that would then sort of make existing networks not viable. So it might be that the sort of level of complexity of the human brain would mean that adding new cells would be sort of damaging in some way. So there may be a logic for new cells not being possible, but we're getting into very much sort of speculation here. Right?
Got it. Okay, no worries. Now you mentioned neuroplasticity, right? So just out of curiosity, what tends to stimulate that more? Is it strength training or a cardio-based workout? Like what tends to stimulate that more?
I think so. Most of the research has been done with cardio stuff. simply because it's
Yeah.
easier to get your rats running
Yeah.
on a wheel. They love it. You stick a little hamster wheel
Yeah.
in a cage, and they'll jump on it.
Got it.
So there's definitely more research about cardio stuff. Going back to that idea that there's a huge cascade of different responses that happen when we exercise. It looks like different chemicals, different substances, different effects come to different extents with different kinds of exercise. But certainly for the neuroplasticity, the work I've seen has most strongly associated with cardio stuff. Cardio work triggers something called BDNF, brain-derived neurotrophic factor, which is what gives the capacity for nerve cells to be plastic, as we're saying. It encourages growth of these possible connections, and may or may not in humans trigger new growth of cells as well, like neurogenesis. But certainly in rats and other rodents, cardio stuff triggers BDNF quite reliably.